Flaps are an essential part of any airplane, as it helps the pilot start or land at low speeds with a minimized risk of stalling and with more control. First, we need to understand the aerodynamics of a wing to know why we need flaps. Airplanes generate lift through the wings. The airfoil, as we call it, is a cross-sectional area of the wing that is shaped to allow different pressures to arise from the wing's top and bottom sides. The top side is rounded, while the bottom is flat. When the airplane moves, the air will divert around the wing. Since the top is rounded, the air has to get out of the way more than on the flat bottom side. However, it doesn't take longer for the air to travel the extra distance, it instead speeds up to reunite with the slower air that took a more straight path on the bottom side. This phenomena is called the Venturi effect, or similarly the Bernoulli principle. You might have encountered this illustration before, demonstrating how a gaseous substance will act in a thinning of a tube. The gas will not slow down in a thinner tube, but actually speed up, due to the gas behind it with a higher static pressure now pushing on a smaller density of air, forcing it into the smaller tube. But to get the same amount of volume of gas through at the same time, it has no other option than to speed up and drop in static pressure to reach an equilibrium in static and kinetic pressure. Back at the airfoil, we can now draw the conclusion that the air on the top side will speed up and lowering the static pressure, while at the bottom side, the air will remain almost at the same velocity and therefore have a higher pressure than the top side. The lower pressure on the top will now be acting as a vacuum in a way. The higher pressure underneath will now push to fill that lower pressure to reach an equilibrium in static pressure and will push the wing with it, lifting the wing and in turn the body as well. However, that is not the full story, as a plane with really thin wings can also fly. This small profile would not create enough difference in pressure, and yet it still flies. Well, what we have discussed is true, but doesn't explain all of the lift we have. A big portion of the lift comes from us redirecting the air down through our camber. And if you've heard about a cool guy named Isaac Newton, you know that every action creates an equal and opposite reaction, meaning that we push something down, so we are thrown up. You could say that we are always double jumping in the air. These phenomena together makes up our total lift. What happens when we lose lift? Well, we lose lift when there isn't a big enough pressure difference to lift the wings, and they become turbulent. This difference in pressure that can lift the wings is only achievable if we have what is called a laminar flow. And if it isn't laminar, it is turbulent. Unless it is molecular flow, but don't worry about that. When we have laminar flow, the air will stick to the wing like a glue through the Quanda effect. But when the velocity of the air over the wing is too low, the glue-like air will become unstuck, and the surrounding air will have time to equalize the top side air pressure, and we no longer have lift. So what are flaps? Well, they're there to keep laminar flow. There are several ways we can prolong this using the Quanda effect. We either extend the chord or increase the camber. This is what flaps are doing. We're making the airfoil more round to keep the laminar flow at lower speeds than we otherwise would, or we make the wing wider. So in a normal situation, we're gonna use these for takeoffs and landings. So what happens when we extend the flap? Let's extend the flap. We can now see that the roundness of the top side, the camber, has increased. As previously mentioned, this will cause the Quanda effect to keep the laminar flow as we slow down, and we will keep flying. The further we extend the flap, the slower we can fly, up to a point where the weight of the plane will pull down more than the lift force we produce. So why don't we fly with flaps out all the time? Because with increased lift, we also increase induced drag, which will pull the plane backwards by the vortices created that will make our total lift normal be behind the airfoil normal. So, when we talk about flaps, we are referring to 4 types. We have plain flaps, split flaps, slotted flaps, and Fowler flaps. Plain flaps are the most basic flap. It has a section of the wing that deflects downwards to increase the camber to generate more lift and drag. Split flaps are split into 2 sections, one that stays in place and one lower part that deflects down. The lift and drag is slightly better than the plain flaps, but are rarely used today. Slotted flaps look like plain flaps, however, it has a hole between the wing and the flap to let air pass through from underneath. This slot will greatly increase the lift because of the high pressure air from underneath will reduce the boundary layer, which will keep the laminar flow from becoming turbulent on the trailing edge. Fowler flaps is the most efficient version, It extends the chord line and also the camber by first moving backwards and then deflecting down. This combination will increase lift significantly. Now, why don't we combine the properties of the Fowler flap with the slotted flaps? Would that work? Yes, and we call it the double slotted Fowler flap, and it has 2 slots in the flap to take advantage of all that flaps can give us. If you found this video informative, don't forget to exercise a few times a week to keep your mental health and focus in tip-top shape. And thank you for watching.